So remember, the key to solving these equations is looking at how they were built and then taking them apart. So the first one, x plus 7 equals 13, was built by adding 7 to our variable. How do we take it apart? We will subtract 7. Very good. We make sure we do it to both sides of the equal sign so it stays balanced. You get x equals 6. And of course, you could go back and plug it in, put the 6 in where the x was, and make sure you get the same value on both sides. Number 2 here, 5x equals 45. What do we have to do to solve that for x? We have to divide by 5. Very good. Making sure we do it to both sides. X equals 9. The next one, 3x minus 5 equals 7. Where do we start? We're going to add the 5 to both sides. So 3x equals 12. And then what? Divide by 3. So x equals 4. And again, you could go back and replace x with 4. And you could do your order of operations to make sure that side comes out to be 7. So it's the same value on both sides of the equation. Well, down here, 17 equals 2x plus 9. What are we going to do first? We subtract 9 from both sides. So 8 equals 2x. And then divide by 2. So 4 equals x. Now, some of you don't like having the variable on the right side. So you can take this 17 equals 2x plus 9, and you can rewrite it as 2x plus 9 equals 17. Remember, these two things are equal, so it doesn't matter which side they're on. Think of it as just looking at the scale from the other side. It still has 2x plus 9 on one side and 17 on the other, so it should still balance. Okay, over here, number 5, what do we have to do first? Well, we see the variable appears twice. Can we just push them together and combine them? No, they're on opposite sides. The equal sign's right here. To combine them, they would have to be on the same side of the equal sign. So since they're on opposite sides, that means we're going to have to get rid of one of them. And we'll get rid of the smaller one, which is the 3x. So to get rid of it, we subtract it since it's positive. That makes it go away. That leaves us with negative 2 on the left side. We still have to take 3x from the other side. So we subtract 3x from the 5x. We can only add and subtract things that have the same name. So 5x minus 3x is 2x. We still have the negative 18 or minus 18 there. Now what do we do? We will add 18. Negative 2 plus 18, 16. Over here the 18 is gone, so we just have 2x. And then divide by 2. It's definitely that point in the night, isn't it? So we get 8 equals x, or x equals 8. Okay. And before I go any further, I want to talk about our first test. Those of you in New Richmond should have received your test back in the email this morning. If you open it, if you cannot see, it is marked in red ink, for just like on my computer screen here. If you open it up and you cannot see the ink, try to open it on a computer at WITC. Sometimes if you don't have the most recent version, or if you don't have a version of Word that's as recent or more recent than the one I have, sometimes the inking does not show up. But the WITC lab computer should have the inking function in it, so you should be able to see it. If that still doesn't work, send me an email and I'll just send you a summary of which problems you got wrong so you can redo them. Now, with these tests, you are allowed to do what I call corrections. What that means is you can redo the ones you have wrong. When you redo an incorrect problem, on the original test, I don't require you to show work, but on the corrections, you do have to show your work step by step as to how you got the answer. I'm not real picky about it, but I just want to see enough that you know what the process is, that you didn't just look at the answer on somebody else's test and copy it down. You are allowed to work together, though. If you look at it and you just cannot figure out how to solve one, come to me and ask. I'd be happy to sit down with you and go over it step by step, whether it's in face-to-face or through email, or if we have to set up a conference on ITV, or sit down with a classmate and ask them. As long as you can see the steps and you can show the steps to get there, I don't really care where you get that answer from. I just want to make sure you've seen how to do the problem correctly and you have it written down somewhere so you can look back at it again later. Now, those of you here in Rice Lake, you can just do that on the paper and hand it back to me. In New Richmond, you can either write it on the paper, give it to someone there to fax to me, scan and email to me, I should say. Or you can just send me an email and tell me, I had problems 3, 7, and 18 wrong. For number 3, I should have done this, and here's the answer. Number 7, you add 4, subtract 7, blah, blah, blah. Here's the answer, and so on. If you have any questions on corrections, let me know. I'm not going to go over any questions on the test tonight. I do want to make you take at least a couple of days to look it over on your own and try to figure them out. I do give you a couple of weeks to get those corrections done. So 2 weeks from tonight, you should have them done. So that gives you plenty of time, if you can't figure them out, to ask questions in class a little bit on Thursday, and then at some point ask help from a classmate or from me, or even from another, somebody in the library or Success Center or Student Assistance Center, whatever. That should give you plenty of time. So we'll talk about those a little bit more next week, but make sure you're going through those tests. Don't throw them away, whatever you do. You do get then half your points back. So what that means, for this class, a passing grade is considered a C, which is, well, technically a C minus doesn't work. That'd be 78%. A passing grade is 80% or higher. So if you ended up with a 60% on your test and you do corrections, getting that corrections brings that 60 up to an 80%, which is a passing grade on the test. Even if you had a 92%, doing those corrections gets you back 4 points. At the end of the semester, every few points can count. Okay, so like I said, hold on to your tests. If anybody in New Richmond, if you've checked your email and you didn't get a test back, send me an email message and I will respond to your email with the copy of your test. I just responded to your standard WITC email address that was loaded in Blackboard. So if that's not working or if it didn't send to you, let me know and I will send it. I'll respond to your email with another copy. Okay, so enough of that. Yes. Whatever's easiest for you, if you can put them on the test and they can fit on there, that's fine. Otherwise, you can put them on another sheet of paper and either staple it or scan it or whatever. Okay, so to start off Unit 2, we saw there at the beginning we were solving some equations, and we have solved some pretty complex equations going through this. Things like 3 times 5x minus 7 equals 24. We didn't do one like this at the beginning, so I'm going to throw this example up there. How would I solve this equation? Well, I see parentheses that should always scream at us, do something here first. Is there anything I can do inside that set of parentheses? No. 5x minus 7 cannot be combined. We have 5x and we have 7. Well, technically, that's negative 7, and its label would be 1 since there's no label there. So they have different names. We can't subtract them. So the second question then, as always, is there anything that can be done to the parentheses? And that is multiplying by the 3. Now I'm just going to distribute. 3 times 5x gives us 15x. And 3 times negative 7 is negative 21. Good. That equals 24. Now what do we do? Now that we have it down to the variable only appearing once, what do we do to solve it? We're going to add 21. Very good. So we're left with 15x over here. 21 is gone. 24 plus 21 is 45. Perfect. Now, one of the things we're going to do tonight is we're going to start applying these equations to geometric problems. And to deal with geometric problems, of course, we have to come up with some of our geometric shapes, our geometric constructions, we call them. And in geometry, the most basic item that there can be in geometry is this thing right there, a dot. It's called a point. And all it is a location. It has what we would call 0 dimensions. A dimension is a direction in which it can be measured or a direction in which it can move. That location or that point, however, is used to construct everything else in geometry. For example, if I take that point and I move it in a single direction, I have created a line segment. Now, a lot of people would refer to this as a line, but technically a line goes on forever in both directions. A line isn't terribly useful in practical geometry. So most of what we work with is really a line segment. It has that start point and end point. The length of that line segment is equal to the distance that that point moved. And this, by the way, would now have 1 dimension because the point was moved in a single direction. It can be measured in a single direction. It now has a length. Well, we're going to come back to this construct to construct areas in a little bit, but let's go to something slightly different. If I take that point and I go in a single direction and I keep going in a single direction, it makes what is called a ray. An array, its length is infinite from its starting point. A ray can be totally defined by 2 things. One, its starting point. More specifically, the location of its starting point. Well, we would locate its starting point by making, we'll talk more about these grids later on in the course, but by looking some sort of a grid, like directions, north, south, east, west type directionals. So there's its starting point. The second thing that defines it is its direction. From that starting point, it goes off in a specific direction. That direction is measured from the east location here, and that is usually referred to as 0 degrees. So let's say that's 13 degrees. So this ray starts at that center and goes off in the direction of 13 degrees. This comes from navigation. Navigational, now the directions and the rotation might be a little off, but from navigating, there was always 0 degrees, and then you rotated from there. So that's why they defined angles off of this. And to define an angle, what they did, if they had that common starting point here, let's say they had that array coming off here, let's say this is still 13 degrees, then a second ray that came from the same starting point. So that same starting point of the first ray, that common starting point is called a vertex. So from that same starting point, it goes off in a different direction. So these two rays with that common starting point but going in a different direction have made what we call an angle. Let's say that this new direction here, that might be at 51 degrees. The size of the angle was always defined to be the difference in direction. Well, what's that mean? Well, we have a 51 degree angled ray. We have a 13 degree angled ray. We subtract, that's 38 degrees. There is 38 degrees between them. That is a 38 degree angle formed. Now, that's probably very different than what you've seen angles defined as before. This was the original definition of angles. Now, in recent years, and by recent I mean like the last 100 years or so, navigational skills have become less and less common. So what they have done is they've pulled back and they've defined angles, still the same degrees and whatever. The angles end up being the same size. The definition is just slightly different. If we start out moving in a direction and we turn all the way around so that we're heading in that same direction, how many degrees have we turned? Yeah, a complete turn is 360 degrees. If I am going in a certain direction and I turn so that I'm now going back in the exact opposite direction, how far have I turned? 180 degrees. Or if I'm going in a specific direction and I now turn, so I'm going exactly perpendicular is the word, but in a square corner to the original direction. How far have I turned? 90 degrees. Well, where did I get the 180 from? How did you come up with 180 degrees there? Yeah, it was just 360 divided by 2. It was half of a full turn, so it's half of the 360 degrees. How about the 90? How'd you get that? Bless you. 360 divided by 4. It's actually a quarter turn or a fourth of a full turn. So our angles have now become defined as a fraction of a full turn. So if I have an angle that's given as 38 degrees, like we saw, that is defined to be 38 3/60ths of a full turn. Does that make sense? Okay. So now we're going to look at some relationships with our angles. So let's say we have an angle, so two rays have that common vertex. But now we're going to have a third ray from that same vertex. We have actually created several different angles here. We have the original angle right here. Now, by the way, there would also be with that original one, there would have been this really large one out here that's always just, the rest of the full turn. We're going to stick to the small angle that's in between on the inside of the two rays for now. But we have that little one that's between them, but then we have this new one that's formed by this new ray and the outside ray. And we also have one that's a combination of them, like that. When they share a common side like this, they should actually have to share a vertex and a side. These are what we refer to as adjacent angles. Adjacent means touching or in contact with or next to. These angles are next to each other. They're touching. They share a side. The angles are what we call additive. Now, additive also implies subtractive as well, though that's not really a word. So if I look at these angles, if this small one here, let's say that's 26 degrees, and this one down here is 32 degrees, this bigger one here can be found by doing what? Yeah, adding them together. 26 plus 32 is 58 degrees. Now, I said subtractive. Subtraction is just part of addition, so it's really just additive looked at in a different way. If I give you an angle here that is 84 degrees, and then we have another ray that comes off of that same vertex, making an angle here that is 22 degrees. How would I find this angle right here? Well, if I call that x, x plus 22 has to equal 84. So I would solve that by subtracting 22, x equals 62 degrees. So those adjacent angles can be added or, in this case, subtracted to find missing angles in the set. Now, those adjacent angles can form special relationships. Here we have two adjacent angles that form a straight line. If I tell you that one of the angles is 72 degrees, how would I find this other angle over here? Well, it'd be 180 degrees minus the 72 degrees would be 108 degrees for that angle. Because they add up to a straight line, they must combine to be 180 degrees. That is what we call supplementary. So supplementary angles add up to 180 degrees. Now, of course, an angle that is a quarter turn or makes a square corner here is called a right angle. Usually it's indicated by putting a square in the corner like that. If I take off from that and I tell you that this angle here is 68 degrees, how would I find this other one over here? Come on. That one. It wouldn't be 180 degrees anymore. It would be 90 degrees minus 68 degrees is 22. So that's going to be 22 degrees. When we have two angles, especially if they're adjacent angles that add up to 90 degrees, they're called complementary. Now, if you're anything like me, I could remember those two words real easily, supplementary and complementary, but I sometimes struggled to remember which one was which. Well, complementary angles add up to a right angle, and you get complements when you are right. So what we've shown here is we've shown a situation where two things add up to a total. A plus B equals the total. Either two angles add up to 180 or 90 degrees. There are other things we can run into. Another situation would be A minus B. Two things subtract to make a known difference. And then the third situation we could have is the two of them have to be equal. Well, let's look at some examples here. If I tell you that this angle here is 64 degrees, and I tell you that this angle here is 2x plus 6, I ask you to find x. What is the relationship between these two angles? Because these are supplementary, because this is a straight line across here, they add up to 180 degrees. So 2x plus 6 plus, now I'm going to drop the degree symbols just so we can work with them here, plus 64 has to equal 180. Now to solve this, I see the variables on the left side, but there are things I can combine. So I can do the positive 6 and the positive 64 make positive 70, so 70. So the 2x is still there, so I have 2x plus 70, and I haven't done anything on the right side yet, so that's still 180. Now what would I do to start solving that? Subtract 70. So 2x equals 110, and then we divide by 2. X equals 55. Now we have to make sure we go back and answer the question. Here the question was just find x. So x equals 55 is the answer. The reason I caution make sure we go back and find the question is sometimes we'll run into things like this. Where we have two x plus 11 and 3x plus 19 might be asked to find the angles. What's our relationship here between the two angles? They still add up to 180. Very good. So 2x plus 11 plus 3x plus 19 equals 180. From there, what are we going to do to start solving this? Combine like terms. The x appears more than once, but they're both on the same side of the equation, so I can just combine them together. 2x and 3x, 5x. 11 and 19 is 30. So 5x plus 30 equals 180. Now what? Subtract 30. Very good. 5x equals 150. And then divide by 5. So we get x equals 30. Are we all done? Well, let's go back and make sure we've answered the question. The question is find the angles, not find x this time. So if we're asked to find the angles, we have to go back and put 30 in where x is. So 2x becomes 2 times 30 plus 11. We do the order of operations. 2 times 30 is 60. Plus 11 is 71 degrees. Now at this point, I could take 180 and subtract 71 to get the other one. But I want to be sure. I'm going to double check. So 3x is going to become 3 times 30 plus 19. Again, our order of operations, we multiply first. 3 times 30 is 90. Plus 19 is 109 degrees. So now I can double check. Do these two add up to 180? Yes, they do. So there's a good chance that that is the correct answer. In your notes, I want you to find these two angles. Find the angles. We'll talk about it in just a minute. So looking at this, what's the relationship between the two angles? They add up to 90. So 3x plus 7 plus x plus 11 has to equal 90. From there, what do we do? Not everybody at once. Oops, that should be a 90 there, shouldn't it? Just a second, let me put the hamster back on the wheel. And okay, that's 90. So 3x and x make 4x plus 7 and 11 makes 18. Good. Now what? Subtract 18. 4x equals 72, and then we divide by 4. So x equals 18. We're not done yet, of course. We have to go back and put that into each of them. If x is 18, 3x plus 7 is going to be 3 times 18 plus 7. 3 times 18 is 54, plus 1 is 61 degrees. Here, if x is 18, 18 plus 11 is 29 degrees. Do those add up to 90? Good. How many of you had 61 and 29? Show of hands. Okay, anybody have any questions on how we found them? So here we have intersecting lines. These lines intersect, and let's say that this angle formed here is 39 degrees. What's this angle here going to be? What's the blue angle going to be? (180) minus 39 is 141. This still makes a straight line across here. So those two still have to add up to 180. They are still supplementary. Well, now that I know that, what's this angle over here have to be? Yeah, 180 minus 141 is 39. That has to be 39 degrees. How about this one down here? Well, you probably just see a pattern developing here. 180 minus 39 is 141. That's 141 degrees. When two lines intersect, it forms four angles, but they come in pairs. that are opposite each other. These two angles are opposite each other. Notice they are the same, they're equal. These two angles are opposite each other. They are also equal. Those pairs are called vertical angles. And the relationship between vertical angles is they have to be equal. So if I have a pair of angles like this, or a pair of lines that intersect like this, and I tell you that this angle over here is 2x plus 7. And this angle over here is 4x minus 11. And I ask you to find the angles. The relationship here is now slightly different. These angles do not add up to a total. They don't add up to 180 or 90. These two angles are equal. They're the same. So now 2x plus 7 has to equal 4x minus 11. How are we going to go about solving that now? Well, the variable appears twice, but we can't combine them this time. We can't just push them together anymore because it's once on each side. What's that? We're going to subtract the smaller one, the 2x. That's gone. Leaves us with 7 on the left side, but we have to make sure we subtract 2x from the other side. So we take it from the 4x to get 2x. And we still have that negative 11 or minus 11. Now from there, what do we do to solve? Add 11. So 18 equals 2x. And then divide by 2. Good. So 9 equals x. All done? No, what do we have to do yet? Plug in the x value to find the angles. So if x is 9, 2x plus 7 becomes 2 times 9 plus 7. Order of operations, 2 times 9 is 18, plus 7 is 25 degrees. Now this one should be the same. I'm going to double check it just to be sure. So 4x becomes 4 times 9 minus 11. 4 times 9 is 36, minus 11 is 25. So those do come out to be the same value. So the angles are 25 degrees. How would we find that angle right there, the purple? Well, this is just adjacent angles. It's just not obvious. If I had labeled this angle like this, it'd be a little more obvious, wouldn't it? Well, what is that angle? 90 degrees, because it's labeled with a square corner. So if I call this purple angle x, I know that x plus 90 has to add up to 118. So I subtract 90. X is 28 degrees. Oh, let's see here. So let's see that we have that. I want you to, in your notes, find x. That's not going to work. I'm going to change that for you just a little bit to make it easier on you. We'll make this 6x minus 9 minus 13. That'll work better. Let's try that one. Sorry. So find the value of x. So if we look at this one, this angle over here is 90 degrees. Those two, the 2x minus 11 and the 90, have to add up to the big one. You could have also done 6x minus 13 minus the 2x minus 11 has to equal 90. That's a little more difficult because you're subtracting negatives, but it should work out as long as you handle the negatives correctly. So here, we are going to combine the negative 11 and the 90. What do we get? Actually, positive 79. Now, there's an x on each side. What do we do? We'll subtract the smaller one. We'll subtract the 2x. What's that give us? 79 equals 4x minus 13. Good. And then add 13. 92 equals 4x. And then divide by 4. So 23 equals x. And we were asked to find x. So x equals 23 is our result. Okay, it is time for a break. We're like a minute early, but let's go anyway. It's 4:19. Let's come back at 4:29. So we're going to shift gears a little bit now for the second part of the course, or for the second part of the night, I should say here. And we're going to look now at a different geometric concept. We're going to start out with perimeter. Perimeter is just a length. It is a distance around an object. So if I have a triangle like this that has sides of 18 inches, 21 inches, and 25 inches, the perimeter is just going to be found by adding up the sides. I might do 18 plus 25 plus 21. If I add those all up, I am going to get, was that 64 inches? That's the perimeter. So we could have a triangle where I tell you that this side is 13 feet, this side is x feet, and this side here is 20 feet, and told you that the perimeter is 50 feet, how would we go about finding x? Well, that perimeter is found by adding up the sides. So it would be x plus 13 plus 20, and we know that the perimeter is 50 feet. So I can put the 50 in there. Now, what can I combine here before I start to solve? 13 and the 20, which makes 33. Now what? Perfect. We subtract 13, so 37 equals x. Oh, not 13, that should be subtracting what? 33, thank you. How about we subtract 33, we get 17 equals x. It's that point in the day. Yeah. Then a miracle appears. So yeah, so we had that was a 33, we get 13 plus 20. So we subtracted the 33 to get 17 equals x. So we could use that for now. I fully acknowledge that if I'm working a problem like this on my own, I'm probably not going to bother writing out the equation. I'm just going to take it. I know if the perimeter is 50, I subtract the sides that I know. I do the 50 minus 20 minus 13 leaves me with 17. I don't bother writing out an equation for these simple problems. But we're doing it because we have to get used to writing those equations so that when we hit a more complex problem, we know how to set it up. We saw one similar to this on the test. Let's say we have a rectangle with width of 13 inches, has a perimeter of 62 inches. Find the length. Well, I tend to draw pictures in these types of problems. I won't claim to draw good pictures, I just draw pictures. There's a rectangle. We know the width is 13 inches. Well, that'd be 13 inches over here as well. One of the properties of a rectangle is that opposite sides are the same length. So this side and this side must be the same length. Well, then the length is going to be the long side. So these two are both the length. I'm going to label those as x. So the perimeter would be found by adding those up. So I would have x plus 13 plus another x plus another 13. And I know the perimeter is 62 inches. So I put 62 in for P. So now I can combine things here. When I combine stuff, what am I going to get? 62 equals 2x plus 26. Good. X and x combine to make 2x. 13 and 13 make positive 26. Then what? We'll subtract 26. 36 equals 2x. And we'll divide by 2. 18 equals x. So x is 18. Is that what we're asked for here? Yeah, find the length. X represents the length. So 18 inches is the length of that rectangle. We can use this, by the way, to come up with a little bit better formula for the perimeter of a rectangle. If these are the widths and these are the lengths, the perimeter is length plus width plus length plus width. If I combine like terms here, L and L combine to make 2L, plus W and W combine to make 2W. So the perimeter of a rectangle, at least, is equal to 2 times the length times 2 times the width, or plus 2 times the width. That formula would shorten up the calculation we just did by allowing us not to have to combine after we put numbers in. It also allows us to look at slightly more complex perimeter problems. So a rectangle with perimeter of 92 has a length 6 inches greater than its width. Find the length and width. So let's draw a rectangle here. We have the width, we have the length. Perimeter is 2 times the length plus 2 times the width. However, and we know the perimeter is 92. Well, we still can't solve that because we have 2 variables in there, the length and the width. But there is a relationship between them. The length is 6 inches greater than the width. So the length is the width plus 6, or 6 plus the width, whichever way you want to put it. So now we can use that in the formula over here where the length is. It's still 92, but instead of 2 times L, it's 2 times, in parentheses, we're going to put W plus 6, because the length is equal to the width plus 6. Then we still have the 2W over here. Now it's a matter of solving the equation. What are we going to do? We're going to distribute the 2. You've got it. 2 times W is 2W. 2 times 6 is 12. And we don't forget about the other 2W over here. The left side is still 92. And then well, 2W and 2W make 4W, and we still have the plus 12. Then we will subtract 12. So 80 equals 4W, and then divide by 4. So 20 equals W. All done? Let's make sure we answer the question. It said find the length and the width. Well, W equals 20. That is our length, or width, sorry. Inches appears in the problem, so that would be 20 inches. We still need to find the length, which is W plus 6. So it's 20 plus 6, or 26 inches for the length. Other geometric formulas we run into. Formula for area. We're going to stick to the area of a rectangle for now. This technically could be built from that single point again. Later in the course, we're going to look at areas and volumes in much more detail. For right now, we're just going to keep it simple. If that's the length and that's the width of our rectangle. Now, not only do opposite sides have to be the same of a rectangle, but of course, all the angles have to be right angles, or 90 degrees. The area of a rectangle is just equal to the length times the width. In fact, we usually don't even put in the multiplication, just A equals LW, the two letters next to each other, implies that they're multiplied. A rectangle with area equal to 48 square feet has a length of 8 feet. Find the width. So here's our rectangle. We know we have a length of 8 feet. And we're looking for the width. Well, I always write down the formula. Area is length times width. And then I fill in what I know. Do I know the area? Do I know A? 48. Length times width. Do I know the length? Yeah, the length is 8. Well, the width better be what I'm looking for then. To find the width, I'm going to divide by 8. We get 6 equals the width. So that is 6 feet. By the way, we could have used the units in here if we wanted to. I just want to show you this. It would have been 48 square feet equals 8 feet times W. And when you divide it out, divide by 8 feet cancels out. Leaves you with the W on the right side. Over here, 48 divided by 8 is 6 still. Feet squared divided by feet is just feet. So it does come out to be 6 feet. The units would work. Okay, so the last thing we want to look at then is volume. Volume of a box is what we're looking at tonight. In volume, we have the length and the width. These are basically just the area of the bottom of the box. We can think of it being that. That's just the area of this bottom of the box, the length and the width. And we have the height. You can think of the height as being this bottom of the box just being stacked up and over again to make it thicker and taller. So the volume is length times width times height. Now again, somewhere around week 12, we're going to look at some much more complicated areas that don't necessarily apply to that formula, but for right now, we're going to keep it simple. So let's say we have a box has a length of 12 inches and a height of 8 inches. If the area is 480 cubic inches, find the width. The width, of course, is the only piece left unspecified. So in our formula here, do I know the volume? That's the area up here. This should say volume. Sorry. I'm really off tonight. I'm sorry. So do we know the volume? 480. Do we know the length? Length is 12. Do we know the width? No, the width is what we're trying to find. Do we know the height? Height of 8. We better know the height because we can only have one thing unknown if we're going to solve these equations. So the 480 is going to stay there. On the right side, we have to combine what we can. This is all multiplication, so I have to combine the 8 and the 12 multiplying. And what is 12 times 8? 96. Perfect. Now to solve this, what all do we have left to do? Divide by 96. 480 divided by 96 is 5. The width is 5. The units we were using was inches. Okay, now in some of my math lab homework, they're going to have you applying these formulas, and they're going to have you looking at them in kind of weird shapes. Might look something like this. Let's see, if carpet costs $6 per square yard, how much does it cost to do this room? Do this floor, we'll say. So I got to put in some dimensions here. Let's say this is 2 yards, 5 yards, 4 yards, 8 yards, 1 yard, 4 yards, 6 yards, and 6 yards. Well, to do this, I have to somehow divide it up into rectangles that I can find the area of. I usually either pick a direction, either horizontal or vertical, and I make all my dividing lines in that direction. So here I just made vertical cuts until everything was cut into rectangles. Then I have to find the area of each of them. This first one here, to find its area, I need 2 dimensions that make a right angle. Do I have them here? Yeah, I have the 5 times the 4, right? 5 yards times 4 yards is 20 yards squared, 20 square yards. This second one here, moving back to the left, however, is a little trickier. What's this dimension here going to be? This whole piece here is how far? 8, right? All the way across, that's labeled as 8 yards. So up here, that whole distance would have to be 8 yards, correct? This piece is 5, so how much is left? 3. That piece would have to be 3 yards because 3 plus 5 equals the whole 8. Going the other way now, this piece is 2. What's this piece here? This one right here. That has to be 4 because if this is 4, they're opposite sides of a rectangle, this must be 4. So that's 4 plus 2. So that second rectangle is 3 yards by 4 plus 2 is 6 yards. This third piece, the first side is easy. That side's given as 4 yards. The next one is more complicated again. Let me erase some junk and get it out of our way here. We know this whole side from here down to here turned out to be 6 yards. That was the 2 plus the 4. This side here then, all the way down, has to also be 6 yards. To get what this piece is then, we're just subtracting this 1, which leaves us with 5 yards. So that is 4 yards by 5 yards, or 20 yards squared, or 20 square yards. The final piece here, 4. This is 6 yards. That part's easy enough to do. What's this piece? Well, this is 6, and this was found to be 5. So 6 and 5 make 11 yards. 6 times 11 is 66 yards squared. To find the total area, we just add up those pieces. So that is what? 58, 66. Is that 124 yards squared? Now we have to answer the question yet. I know it feels like we've done enough, but it's $6 per yard. So the cost is going to be 124 yards times the $6 per yard, which is going to give us what, 744? Is that correct? Okay. So you can see the hardest part of this is dividing this thing up into rectangles and figuring out what these missing dimensions are. If you struggle with that, don't get frustrated. A little more than half of students do struggle with that. So if you're struggling with it, if you're getting confused trying to find those missing sides or the sides you need to find the areas, be assured that you are not alone. You're not the only one that's having problems with that. We're covering it here now because we are going to cover it again in about 8 more weeks. So we want to hit it a couple of different kind of times because, like I said, it is a skill that a lot of students struggle with. Okay, well, since we had a test last class, there is no quiz today. But instead of a quiz, do test corrections. Again, you don't have to have those done by next class. I do give you about 2 weeks to do test corrections. Make sure, like I said, you can work with someone else if you want to, but make sure you have the process down on your paper so that I know you've seen how to do the process. There is, however, a new homework assignment that will be due for Thursday. Okay, I'll let you guys have the last 25 minutes here if you want to start on the homework or if you want to work on test corrections. I'll be here to answer questions until 5:20.